Live.
All right. So,
Hello. We are having a technical issue with Mr. Daniel. Of course, he's going to come on board now.
I'm back. Oh, sorry,
Yeah,
guys.
sure.
Sorry. Okay. So, let's just get straight to. We don't have time, so let's just get straight to the class. I'll just share my screen and we'll dive in. Okay. So, um, again, all you have to do is, I'm sure you were sent the machine learning notebook. You just have to go through the Zoom process to set it up, and we'll be together. Right. So remember, let's just do a quick recap. So last week we said we're working on a facial recognition program um, at a very basic level. Um, so we're focusing particularly on deep learning. And then we talked about dependencies and what they're used for. I said they're a couple of codes that you could actually somebody has compiled to do particular functions, and you could just call that to your own code and use that to do some pretty nice stuff, right? We said numpy is for number calculations. We said TensorFlow is for particularly for deep learning. Then we talked about scikit-learn for machine learning too. What else did we talk about? I think everything is pretty okay. Yeah, we talked about matplotlib for graphs and for plotting, right? So I'm sure you guys must have explored with this. Oh wow. I think I'm having a little glitch in technical. I'm sharing my screen. Can you guys see my screen? Okay, fantastic. Yeah, that's all. You're just going straight to. I'm thinking everybody who came from Python class is seeing my screen and has just done the same process we did in Python class to get your machine or your deep learning notebook to come up, right? So I'm just going straight to the notebook. So yeah, so yeah, we say it's not very complex. I'll just give a very brief overview of everything, every cell we have here. So this cell is for importing dependencies. All you have to do is just run it. So I can see Jonathan, I can see Sharon, I can see what's your name? Papa Frido, you have to remind me of your name. Then Abdullah, what's your name, please? Okay, so let's go back to deep learning. Okay, so let me just remove this so I don't have to. Okay, so yeah, all you have to do is run this cell. Once you get it started or set up, run this cell, and oh, everybody needs this. Everybody needs this. Okay, so we're going to do a little sourcing for data, right? We're going to do a little sourcing for data. So let's just go to Google. We're going to do, let's say, Chris Brown, right? Good. So you just click on images. Let's see his images or Hotuna, and we're going to get 20 images of Chris Brown and 20 images of who else? Let's see. Um, a lady this time around. Jennifer Aniston. I hope I got the spelling correctly. So we're going to do facial recognition for both of them. Now, when you're practicing, you could use your own image. It's fine. That's completely fine. So remember, I want to get 20 images, right? So here, all you have, click on one, and then right click and click Save Image As. Let's say Chris Brown 1 or Chris 1. We have our first Chris image. Let's use a very different image this time around. Save image as Chris 2. So we're actually, what we're doing now is we're getting data for the work. Let's get another image. Chris 3. Okay, this is good. Chris 4. Again, you want your data to be as varied as possible. You know what? I'll just call them 1, 2, 3, 4, 5. Yeah, so this one, it has a golden hair. So in case you put a golden hair image, it's supposed to recognize it. Let's call it a 6. We want to get 25, 5 for validate, 5 for 20 for training, and then 5 to test. 7. This is pretty good. Okay. 8. Okay, I think I like this one. 9. Okay, this is black and white. Good. In case you put a black and white image in, it should be something you can see. You can just do this, right? We're going to 25, so you can, if you're faster, that's fine. Let me see. Is anybody having issues? Okay, good. Let's just continue. Oh, I like this. It's on a different hair. So where were we? We're in 11. 1, 2, 3, 4, 5, 6, 7. Okay, there's no 7. We jumped a 7. I like this is on a cap with a tattoo. We don't have a 7. Let's put a 7. Yeah, this is a different image. Save image as where will we? 12. Okay, this is good. Save image as a 13. Let's do this. Again, you want your data to be as varied as possible. That means there are many kinds of angles for the data, right? You don't have to download the same images I'm downloading. Just pick the images you feel is fine. It's going to be as practical as possible. You get to create your own facial recognition program. Is this good? Okay. I like this. It's a little far. And it's a little blur. Yeah, let's try. Okay, let's try. 16. We're almost there. Oh, this is good. This doesn't look like him in a way. Save image as 17. This is good. 18. 19. 20. 20. Okay, so we're done with our trading. So let's just add 5 more for our testing. So when we're done, we can test the model. Let's use this. Um, 21. Oh, it looks young here. Good. This is good. 22. This is good too. It looks pretty young here. 23. Oh, I like this. Trying to make him up as a girl. So let's see if our model is going to learn that too. Chris Brown is pretty a very, very should I say he has a very diverse personality. He's not a one type of person. So oh, this is a JPG. Can we work with a JPG, a PNG? I'll have to change that 7. Let's not work with a PNG. Let's not work with the PNG. Let's work with all JPGs. So I'm replacing that 7. Yeah. Now, if you notice, I pause a little so that the image loads completely, and then it's as clear. Because if you download it, when it hasn't loaded completely, you would have a blurred image, right? Okay, so we have 25. We're good with that. So I'll just clear this out, and then I'll arrange all this into a folder, right? And upload that folder to my drive. So all I need to do is okay, just cut it out and create a Chris Brown folder. Let's call him Chris. And I'll put everything inside here. Fantastic. So we have Chris. So let's do that for Ernestine, and I'll be faster this time around. It's still the same process. Let me see. Let me see. Let me see. Okay. Now I want the data to be as varied as possible. So I don't want to put the same kind of data. I like this. It's 2 images of how this is good. Ah, it's a PNG. Oh, that hurts me. I want singles. Be careful not to download PNGs. You would have errors later. If you're going to work with PNGs, work with PNGs. If you're going to work with JPGs, work with JPEGs. I'm happy we're doing this together. So you take your time. We're doing it. So you see how long it takes to do it on your own. Again, this class is supposed to be as practical as possible. Okay, we have 8. Let's do a 9. Well, Jennifer is not as diverse as Chris Brown, I noticed. I hope do you notice too? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fantastic. We have 15 to go. Uh, please don't be JP, don't be PNG, please. I like you. Yeah, fantastic. It's not PNG. Let me see if this has variations. I need something varied. I need something varied. She always has the same kind of hair. Okay, let's see this one. Now, this time around, we're working with two actors, right? It could be as many as you want. Just make sure that you have enough images of them, right? Because you need to train uh in 16. You need to train with as much data as possible. The more data you use, the better. If you can have 100, that's fine. If you can have 1,000, that's even better, right? Um, okay, like this. 16. Do I have a 16 here? I do have a 16, but I'm not seeing the 16. Why? Okay, let me do 17. Oh, I like this. It's a different setting. I wish there were different. If the picture could even be um black and white, bluish, something different. Because your image could come in any form. It could be in the night. It could be it could be a night picture. It could be an early morning picture. It could be when she's just waking up without makeup, and you want your model to be able to classify that too because it has seen that before. Remember, this is supervised learning. It's based on what you teach it that it knows to do. So if you've not shown it something before, it might be confused as to what that thing is. It might classify it correctly, but it might not be very sure. I'll explain what that means. So let me quickly inspect. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We need to change this 18. I particularly like this one because it's a side view. And this one, 22. And this one, yeah, this is good. 23. And this one, again, wait till it loads clearly. It has to be as clear as possible. 20. Oh, it's a PNG. I have to change that. Um, yeah, like this. It's a different angle. Again, I'm waiting for it to load clearly. Uh, okay, so it's not loading as clear as I would want, but let's just run with that anyways. So this is the 25th picture. Let me see if we have all we need. I don't need this. This is not good. So I'm just going to remove this from here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I'm replacing 18. Yeah. Okay. 22, 23, 24, 25. Okay. So I'm just going to move all this into a particular folder. So I am cutting this out and I'm creating a new folder. And I'm calling this Jennifer. All right. Okay. I want to make this a small letter. Right, so I'm just going to paste everything we have into this place. Okay, so good. So all I need to do now is upload this into my drive. You have to use your drive. So I'm going to come here and I'm going to click on new and I'm going to click on folder this time around, not file. I'm uploading the whole folder, right? So I have Jennifer and Chris, right? Okay, so I can only upload one at a time. So I'll upload Jennifer first, upload, and I'll come back to upload Chris. All right, so it's uploading. Now we have about 11. It's uploading. So let's just go to. Oh, I already have a Jennifer. So what do I do about that? Let me inspect my Jennifers to see. Let me inspect my Jennifers. Okay, so let me inspect this. Okay, we have some Jennifers. Okay, so this is a project I worked on, but we don't necessarily need it. So what do I do? So I'll just change the name so that I don't have. Sorry, guys, I need to. Okay, let me just rename this to Jennifer Annie. Let's put it, or Aniston. All right. Okay. Cool. So now we have it in our collab, right? We have it in our drive, right? So now let's go back to the collab, and I'll show you how we can link that from our drive to the collab. So all you have to do is, let me be sure that you're all following. Some guys are having issues. So guys, if you're having issues, please just hold on. I'll quickly run through this and then come back to answer all your questions, please. Okay, so but rest assured we'll sort it out today because you need to practice this at home on your own rather. Okay, so here. So in case you do not have your drive, you know what? Let me just cancel it and start all over. Okay. So once you click on this suitcase, you would come over here, right? All you have to do is click on Mount Drive. So once you click on this, it will start mounting your Google Drive. It will start mounting your Google Drive. If it doesn't mount your Google Drive and it just gives you a code, it brings out a code, run that code. Once you run that code, it will take you to, it will create a link you have to click on. I just wish I could. Okay, let me copy out. Let me see if I can get the code. Code to mount Google Drive or in Colab. Again, like I said last week, Google is your friend, so you don't necessarily need to keep all the code. Okay, so from google.colab import drive. So let me just quickly type that in. So you should see. You should. Oh, okay. Then what's next? Drive dot mount content slash drive. Okay. Drive dot mount content slash drive. Okay, so you should see something like this. If it doesn't automatically connect you, now because I've connected before, it's not going to bring out this code for me, but if for you, it's going to bring this out. So all you have to do is run it. Now it's telling me my drive is already mounted. That's why. But if your drive wasn't mounted, you would see something like this. Something like this, what you're seeing here now. You just click on this URL, right? Click on it. It will take you to, it will bring you to, it will show you, it will create a new tab, and then it will show you this. All you have to do is click on this particular square, and then it will copy this key. It's like a key, it's like a token to show that it's really you, and then it's for security. So you click on this here, and then come into your code and paste. Come into your code here in this space and paste it here, and then press enter. Once you do that, it automatically connects you to your drive, right? Then you would see your drive appear here. So once I do this, I can see my drive. Everything I have on my drive here is connected to my collab. So remember, Chris and we have Chris and what's her name now? Jennifer, right? If we check, we would see Jennifer Aniston and we'll see Chris. But we don't want it like this. Let's do something more to our data. Let's do something more to our data. So let's create a new tab, a new folder, right? Folder, and call it face recognition, right? And then click enter. Don't mind let's call it recognizer. Recognizer. I have a recognition already, so that's why I don't want to use that here. So I'm just going to move Chris into recognizer. Right, and then I'm also going to move Jennifer into recognizer. Okay, so now I think I explained last week that we need to have train and validation. So training means your model learns particular things about that particular person from the training, and then it uses the validation or the test to compare. So it will try to guess. So once it has learned, the model will now see a new picture in the test or validation directory, and then it will try to guess who that person is. Now, so once it gets, it will compare it against, you have already told you that this is Jennifer Aniston, right? So you're supposed to compare against what you told it is. And it will keep doing that until it perfects, it clearly recognizes Jennifer Aniston. So let's get back to, okay. So if you do that, that change automatically stores in Google, automatically stores here. So now we have a recognizer and we have a Chris and then we have a Jennifer Aniston. But let's do something more. We need to now break our data down into training and validation. I'm going to do something like this. I'm going to come inside here and I'm going to create a okay, not here. I'll come out here and create a new folder and call that my train, right? and then I'm going to create another folder and call it my tests. Then inside here, I'll randomly select 5 images out of 25 to test on, and I'll move them to train. I'll go into train, I'll create a folder and I'll call it Jennifer. Oh, I should just call this Jennifer. Let me call it Aniston. Okay, so I'm going to create this new folder and I'm going to move them here. So if I come out and enter into train, I have them here. Make sense? Cool. I'm going to rename this. So I have 20 left here, but I'll just quickly rename this to Aniston. And I'm going to move it into train. Right? Let's see. Yeah. Oh, okay. Oh, so sorry. This is for train. We have train. This should be for test. So let's move this out of here to test. Yeah. So what that means is in train we have Jennifer Aniston, in test we have Jennifer Aniston. Only that train has 20 Jennifer Anistons, test has 5 Jennifer Anistons. Right? So that's the same thing for Chris. So I think I'll just first move this into train. Then I would go into train and take out, in this case we have 26 for Chris, so I'll just take out 6 randomly. Yeah, and I'll move them into tests. I'll go into tests and I'm going to create a Chris folder and put it inside there. So I guess we're good to go. So what does our test have? Yeah, we're good to go. So if when we come here, the change will reflect here. So I'll just close this and then put it back. So test has Jennifer Aniston and Chris. Fantastic. All right. So now we have to so let's not get to work. So we import our dependencies like you have there in your own, or you have to just run the file. Then for this training directory, we have to show it where it should get the training images from. So in our case, this is our training directory. So you just click on these 3 dots and click copy path, right? So once you click copy path, you could just change this to what it is there. For test, your test in this case is your validation. Don't worry about the terms. They mean the same thing at this point. So good. So once you have that, you're showing, like I explained last week, you're training where to get your train and your test images from. So once you do that, we're good to go. So now we have dependencies and we have training directories and test directories and validation directories. Then I explained that you need image data generator to vary your image. So for the case like Jennifer Aniston now, you would notice that some of them, most of them were just they were very identical. They look the same to a very large extent. So what you could do is use image data generator to vary your image. You could go back to the last video and listen to that properly so you understand what all this means. So you run this and it's telling you that it found 40 images in the training directory, which is 2020, 20 for Chris, 20 for Aniston, and then it's saying it's 2 classes, meaning Chris and Aniston. It automatically does this. And then it found 11 images in the validation directory, which is 5 for Aniston, and then 6 for Chris, right? So, and it's is in two different classes again, which is Chris and Aniston, right? So that being said, all you have to do now is, I'm not sure I explained the model, so I'll focus here today. So I think I explained the concept of transfer learning. So transfer learning is a very large model, a very large neural network. Let me show you what a neural network. I spoke about it last week, but I didn't show you an image. I'm going to show you an image now of what a neural network should look like. Okay. So here we have um, several things. We have input layer, we have hidden layer, and we have output layer, right? So input layer basically means where you input your data. This is layer that takes in your data. In our case, is image. We're pushing in images, right? So we're pushing in images from here into here, right? Into the input layer. This input layer here. Now, from the input layer, it will now take it to create several, or we're going to create a hidden layer. Now, this hidden layer will learn several things about our image. Think of it as it learning the eyes, the nose, the lips, the hair color, how the facial structure is, right? This is the layer that is going to do all that learning. And then once it learns all those things, it will now classify. This is the layer that will classify, is it Chris or is it Aniston, this output layer here. So you could say you put in the information here, or you put in your data here, the calculation is done here, and then the output or classification is done here, right? Very simple. Let me show you another one. Now, this is a larger network. This one is called a deep neural network. It's still the same thing, the same concept. You have your input layer, then you have your hidden layer. In this case, we have many hidden layers, right? You have 3 hidden layers, and then you have your output layer. This could be, now we have 4 output neurons, right? This could be Chris, Aniston, maybe Nicki Minaj, and President Obama, right? For every person, every new classification, it has to have an extra node, right? But if it's only 2 classifications, 1 node is fine, right? So when I say node, I mean one of this circle. And remember, I explained in our last week that one circle will learn a particular thing, then to pass that information to another circle, maybe this circle here, which will pass his own information to another circle here. For example, if this one learns eyes, it will pass his information to this one here, here. This one would learn eyes and probably nose. Then this one will pass, then to pass his information here, and it will learn nose and mouth, eye, nose, and mouth. And this will pass his information here, and this will learn eye, nose, mouth, and maybe facial structure. Then at the end of the day, this will now do the classification and tell you, oh, I know this based on what all my other neurons at the back have told me. This has to be Chris, or this has to be Aniston, or this has to be Obama, or this has to be Nicki Minaj. I hope that makes sense. So for this, what we are working on, we have a very large neural network. In this case, we have a neural network that has 3 hidden layers. But the bigger your neural network, the better it performs. And so there's something Google did for us. Google, Facebook, Microsoft, and Tesla, some very large tech companies. So they created very large models, and then they trained them on a very large data set. Probably think of 1,000,000 images, right? Yeah, that's why they say AI needs a lot of data, 1,000,000 images. And then from that 1,000,000 images, the neural network learns several things about human beings. So it can recognize human beings, right? It knows that if I see a head, a face, a nose and a mouth, a hand, a leg, this is a human being. If I see a particular cat nose or a particular cat picture. This is a cat. But you are now going to take that very large information that it has learned, and then you're going to tell it, I know you can recognize face, but I want you to recognize a particular face. So that means I want you to recognize Betty, or I want you to recognize Jonathan, or I want you to recognize Jonathan's mother, or I want you to recognize a particular person, right? He already knows what a human being looks like. So you're now saying, okay, look more in depthly at this is how Jonathan's nose is. This is how Betty's eyes are, right? So that's what's happening here. So in this case, we're using transfer. We're transferring the learning it has learned on a very large data set, and then we're pushing that into, we're bringing that into our own work, and then we'll add our own layers to it. We'll add our own, when I say layers, I mean our own layers. So for example, the layer might be from here to here, but at the end of the day, we'll add our own 3 hidden layers to it. Don't worry, to make sense when I show you. Okay, so is anybody having issues understanding this? Okay, so yeah, so we're importing a pre-trained network that is called a pre-trained neural network that is called mobile net, right? Mobile net it's a relatively small neural network compared to other larger neural networks. Like this is around 17 MB, because sometimes you might need to create a facial recognition software that you want to work in your phone, and your phone cannot carry, say, 300 MB. A neural network that's like 300 MB, right? It will be very slow and it will require a lot of data and all. So mobile net is created for small devices, right? But it can still classify almost as good as very large networks, right? So all you need to do is you just use this code here. This code imports it, right? So once you import it, you put it into the mobile variable. Remember variable we talked about? Yeah, you put it into the mobile variable, and then we are not going to use the last 6 layers. Remember this when we talk about indexing. What removing the last what's taking mobile this mobile neural network, but we're taking it up onto the last we're removing the last 6 layers. That's what this means, right? So if we run this, good. So you see, we've downloaded it from Google API. And so if we wanted to see what it looks like, all you have to just run the code. You don't have to bother about coding it. You run the code. Good. So if you want to see what the neural network looks like, see how many layers it has. It has about, see how many layers it has. This is layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7, down to this point, right? This is the only layer we're adding to it. This is our own layer. We added this layer to it. Oh, we're doing classification of 2, so this can't be 3. So let's go back. We're doing a classification of 2. So we could just use a 2 here. Rerun it. And do this again. Okay, so now it's 2, right? Meaning that it's either Chris or Jennifer Aniston. Only 2 classifications. Okay, and then we have to compile the model. Don't worry, all you have to do is just run the cell. All right, so once we're done, we've created our model. Everything we've done here was to create the model. Everything we did here was to work on the data, make it more varied. And now we're going to do training. To do training, all you have to do is hit model.fit, pass in your data. In this case, our data was put into data generator here. We took the training directory, we converted all the image to 224 by 224. I wish I could show you the images. I'll show you in the next class. And then we're saying a batch size of 5 because our data is like 20, so it's going to take it in five. So it's take 5 first, take another 5, and then take another 5, right? And then our class mode is categorical. We're classifying different categories of images. So we'll pass that into this place. And then in validation, which is supposed to be our test data, we'll pass our validation directory too. So epochs means train for 20 times. That means go over the data set once, then come back again and go over it again. And every time it goes over it, it learns more. It learns it better. That's what it means. That's what epochs means. Don't worry about verbals. I'll explain what verbals mean once this starts running. Then don't worry about. Let me just wipe this out. We don't need this. Okay, so yeah. So what this does is monitor the validation loss. I'll explain. After 2 epochs, if it doesn't change, if it doesn't reduce, stop the training. That's what this line means. Okay, so let's run it and then I'll explain what again better. So our training has begun. This should be okay. Fantastic. So in this case now, you can see that the accuracy is 0.62. This basically means 62%. 62%. Now in this case, it's 90%. What this means is that, what this simply means is that um, this is the accuracy on the training data set. That's our training path. This is the accuracy on the test data set. This is the loss. Look at loss as the mistake it's making. Look, this is the loss it's making on the training data. Everything you have from here to here, from this side, the left-hand side, loss and accuracy is on the training data. On the right-hand side is validation and on the validation data set, which is validation loss and accuracy. So just basically accuracy on the train on the validation data and loss on the validation data. That's what this means on the right side. On the left side is loss on the training data, accuracy on the training data. How well is it predicting, right? And how bad is it making mistakes? That's what loss means. Validation loss too, and validation accuracy. Okay, so it stopped at 20 because we told it if after 2 epochs, after 2 times you've gone through the data and this validation loss does not reduce, stop the data set, stop it. So if you look at this is 0 point, this is about 5% loss. This about 11% loss. This is about 20% loss. So that means it's increasing. So after these 2, it did not reduce, it increased, so it stopped. It didn't get to 20 epochs. It was supposed to get to 20 over 20, right? But we're not letting it get to 20 over 20 because it has already started making mistakes, right? So let's now see an image. Don't worry, we'll run through it again so it should make better sense. If you're in last week's class, this should make better sense to you. I'll just pick this out, copy path. So we're checking this image to see if it's going to predict correctly. So let's change this to 13. Good. So this is the column for Jennifer Aniston. This is the column for Chris Brown. List there. Let's see. Hold on. Okay, so there's an error with this code. So again, let's troubleshoot it. Let's find where the error is. Okay, so the max value. Let me see the max index. Okay. Okay, names. Okay, let's see what names is. Okay, so let me see the train. Okay, so it's obviously rearranging this. So let me do um okay, let's do an if statement. Okay, so max index. So if max index is equal to 0, right? Print else print this image is an image of, okay, so if it's 0, we know that Jennifer Aniston is 0, so let's say of Jennifer Aniston, else it's Chris Brown. Okay, fantastic. So it's saying this is an image of Jennifer Aniston. So if we check, so guys, you might need to copy this code. You have to update the code you have with you there. I'm not particularly sure why this is showing Aniston 1, but it's fine. I would work on that. It shouldn't show that for you. So let's test another image. Let's test a Chris Brown image. Okay, so let's just copy Chris Brown path. So I'll just come here, change this to Chris Brown and run this. And what image do we test? Let's test 17. Let's see what 17 looks like. Okay, so let's try it out and see. It's saying it's not, it can't find this image. Is that so? Okay, yeah. But testing for a 17, so not a 13. There's no 17 in the folder. So let's do that. Okay. So in this case, this side of it is larger. So let's see. This is an image of Chris Brown. If you want to try it again, let's check it 22. All you have to do is come here, check it 22, and you can just put it 22 here to see what it looks like. This is it, what it looks like. And if you run this, you see this is an image of Chris Brown, right? So at this point, you've trained a classifier. It's not perfect because there are some, if it should be told, honestly, there are some images you would try that are close to, that look like Chris Brown, that it will classify as Chris Brown, right? So that's why you need a lot of data for it to be able to recognize Chris Brown without any issues, right? So yeah, so on that note, signing or we're finishing class today. You can rewatch the video again. If you have any issues, don't hesitate to just send an email, and then I'll see how I can get back to you personally. Yeah, so let me see, do we have anybody having issues? Yeah, okay, so I'll answer some questions. So Ednand is saying, do we have to download 10 of each? Well, you have to download as much as possible. There are places where you can actually get already downloaded data, already downloaded image data sets. But I wanted you to do some rough work, to do some downloading yourself, so you see how it works, right? So that's why we did this. We did that first rough work. Next week we can talk about places where you can get data sets. But then again, if you wanted to do an image classifier that will recognize your mom and your dad, you can't find that online. You need to be able to get your own data for yourself, right? So that's why we follow that route. How? Okay. Ednam is saying he could not recognize. He couldn't find the facial recognition collab page. Okay, yeah, in the last video we didn't send it out, but in this video we did. So all you have to, if you didn't get it, all you have to do is just input your email here, and then we'll forward you the file. And then go to Python class. You can just check the Python video and then see how to set that up for yourself, and then follow this video tutorial if you did not follow through from the start. Does anybody have any other questions? Sharon, are you fine? Are you okay? Did you have any issues? Papa, how did it go for you? Jonathan, for some reason, I feel Jonathan actually, did this pretty well. Lawumi or Latunji, any issues? Let me know. Do we have any issues? So I'll just give you a few. I'll wait 30 seconds for anybody to ask any questions whatsoever, and then I'll respond to them. In the absence of any questions, we would, call it a night or call it a day. So 30, 29, 26, 24. Again, if for the code, you might not recognize or know what everything is used for. I explained the critical parts, the parts you can change, right? And then I give you an overview of the parts you really shouldn't change at this point. As time goes on, I'll be breaking it down into pieces and then to be making better sense to you. Don't worry, we're not doing any other thing outside of what I just did. We're just going to go over it again and again, and then to be making better sense to you. But at this point, if you can get your data and then put it into your collab and everything we've done now, your code should be able to classify. That last cell that we're having that was telling us the wrong thing, you can just recopy this, retype this. If you don't know what this means, go to Python class. This should make sense in Python class. After Python class, this should make sense to you. So that's also possible. Okay, so allow me. I'm guessing your no means no. I didn't have any issues. That's fantastic. Okay, so on that note, I would see you guys next week. Explore, get more data, get different kinds of data, and then if you have issues, let me know. Yeah, just send an email. All right, guys. So nice having you here. Nice being here with you guys. All right.
Okay, thank you, Mr. Daniel. It's such a wonderful section, and I hope we've all enjoyed your section. Thank you very, very, very plenty much.
Yeah.
For the
Great to be here.
students, thank you. For the participants, thank you for coming in. And this will be the end of our week 2. Hope to see you guys in week 3. Please do not forget to submit in your assignments. Put down your assignments at hello@coderina.org so that we can follow them. Remember, I said we have prizes for those who are going to be submitting their assignments to us, and we have a lot of things that we are going to be giving those who are our participants, constant participants. So, thank you guys. Week 2 is done. I hope you've learned a lot. See you guys next week. Of course, I've learned a lot today, anyways. So, yeah, see you guys next week and take care of yourself. Do your assignments. Practice, 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 practice. Okay? Remember, constant practice makes perfect. So keep practicing. And if you have any questions, send messages to hello@coderina.org. Thank you and see you all next week for week 3. Bye.